So let's talk a little bit about the unit circle. So why is this circle called the unit circle? Well, here's why. We know the equation of the circle. It is centered at the origin, so we know h and k will be 0, and the radius of the circle is 1. So that's why we call this the unit circle. So therefore, the equation of the circle is x squared plus y squared is equal to 1. So if I measure this distance from the origin, this is 1. That means every direction from the center to at the end point of the circle is distance of 1, which means this point can be labeled as the coordinate x coordinate 1 and y coordinate 0. And then as we travel counterclockwise, this point we can label it as 0, 1, and then this point we can label it as -1, 0, and down here we have the coordinate 0, -1, and then again we're back to the point 1, 0. Now what makes this circle so special is that we can define our trig functions in this unit circle. So what I'm going to do is I'm going to measure an angle from the standard position, which is the positive x-axis, and then travel counterclockwise. So suppose from the initial side, which is the positive x-axis, and then from here, we're going to create an angle. Let's call this the angle, theta. And let's label this point P, which has the coordinate x, y. And what we're going to do is we're going to construct a right triangle inside the unit circle. So I'm going to drop a line segment from point P to the x-axis. So I have created a right triangle. Now from here, I can use the definition of trig functions such as sine, cosine, and tangent to relabel the length of this right triangle. So let's look at the hypotenuse, since it is important to label that first. The hypotenuse is the distance from the center to the end point of the circle, and because the radius is 1, this distance is also 1. Now, what about the sides? Well, if you recall that this side right here, this point, the y coordinate is y. That means this side across from theta, it's going to be y, since it's parallel to the y-axis. And the bottom length of the right triangle, it's parallel to the x-axis. So we're going to label that to be x. So I'm just going to go ahead and erase this piece because we're not going to need this right now. So I'm going to relabel that side to be length x. So from here to here, this is length x. So now using our definition of sine, cosine, and tangent, we know that sine of an angle is equal to opposite over hypotenuse. So from this right triangle, across from theta, this is opposite, and this is adjacent, and 1 is, of course, the hypotenuse. So therefore, we can rewrite our sine definition as opposite, which is y over hypotenuse, that's 1. So we can say that, therefore, sine of theta is equal to y. So the y coordinate will correspond to the sine of the given angle. So this is super important. Now, what about the cosine definition? We know cosine of an angle is adjacent over hypotenuse. So in this case, our adjacent is x, hypotenuse is 1. So now we can rewrite nicely that cosine of an angle is equal to x. So therefore, I can rewrite the point P as a trig function, sine and cosine. So we know point P is going to be given by x coordinate, which is equal to cosine of the angle, and the y coordinate is sine of the angle. So that's how we can rewrite x and y, which is in a rectangular coordinate system, into polar coordinates, as you might see it in the future studies. They're written as sine and cosine, and the radius is 1 in this case, so there is no r involved because r is 1. Now, knowing that about the unit circle, I can talk about an angle. So let's label this unit circle by giving angle measure. So if you're on the positive x-axis, this is measure 0 degree. Now, as you're traveling counterclockwise, when you're at the positive y-axis, this is 90-degree angle. In radian, it is measured pi over 2. And then as we keep traveling in this direction, when we're on the negative x-axis, we're at 180 degree, which is pi in radians, and keep traveling in this direction. Once we hit the negative y-axis, we're at 270 degree, which is equivalent to 3 pi over 2 in radians. And then as we hit the point 10, we're back to 360, which is equivalent to 2 pi. So once we have completed the entire circle, we have traveled 360 degree. Now, what if I want to use the relationship of sine and cosine for this unit circle? So what if I want to evaluate, say, what is sine of 0 degree? Well, I will be looking at the 0 degree on the unit circle. So 0 degree is right here, and the point that corresponds to is this one. So, and I know by definition, sine is the y coordinate. So the y coordinate of 0 degree is 0. So therefore, sine of 0 degree is 0. So that's the exact value. Now, what about cosine of 0 degree? Again, we look at the 0 degree, and because cosine is the x coordinate, cosine of 0 degree is 1. Now, similarly, you can define tangent. We know that tangent is equal to sine over cosine. So therefore, sine, we rewrote it as y. So tangent is y over cosine, which is x. So we can rewrite tangent in terms of x and y, which will be y over x. So if I want to find tangent of 0 degree, well, that will simply be sine of 0 over cosine of 0. Sine of 0 is 1. Sorry, sine of 0 is 0. Cosine of 0 is 1, which means tangent of 0 degree is 0. And then you can keep going on the unit circle and define what is sine 90. Well, sine 90 is going to be the y coordinate of 90 degree, which is this point right here. So we can say sine 90 is 1. And if I want to find cosine 90, that will be 0. And then we can also talk about 180, 270, and 360, and more from here. So now let's go ahead and find a couple of exact values. So we want to find the exact value for sine of pi. Well, if we go back to our unit circle, so pi is located right here. So that means we're looking at this point. So sine, we said the sine corresponds to the y value. So for this point, the y value is 0, which means sine of pi is going to be 0. Now, what about cosine of pi? Well, again, we're looking at the same angle. We know cosine is the x value, so cosine of pi is going to be -1. So the exact value for cosine of pi is -1. And now for tangent, well, you don't really need to look at the circle. We know tangent is sine over cosine. So sine of pi is 0. Cosine of pi is -1. Therefore, tangent of pi is going to be 0. So tangent is always the ratio of sine and cosine. Now let's take a look at sine of 2 pi. So for 2 pi, we're going to look at this point right here, because 2 pi is equivalent to 360. So again, sine is the y coordinate, and the y-coordinate of this point is 0, so therefore sine of 2 pi is 0. Now what about secant of 270? Well, secant you can rewrite. Secant is the reciprocal for cosine, so this is 1 over cosine of 270. So 270, let's go back to our unit circle. So 270 is right here. So that means we're looking at this point on the unit circle, and cosine is the x-coordinate, and the x-coordinate of this point is 0. So cosine of 270 is 0. So we have 1 over 0, which means secant of 270 is undefined. Okay, so I hope this helps.